Hello and welcome to another lesson on trig equations. So we're going to be covering 7.6 and 8.1 in your textbook, and we're going to focus on basically doing some practice problems while also focusing on elevation, relating tangent to slope. So let's get right into it. So we're going to be focusing on this problem here, finding the exact value of the expression tangent of arc cosine for this ratio of negative 12 over 13. So take a moment and give it a shot, and we'll go over it together. Okay, so starting off with this one, I'm going to simply state that we have arc cosine of this ratio. As a reminder, cosine theta is referring to a ratio of x over r. If we draw the unit circle really quick for quadrants, we can say that, remember, arc cosine is limited to the quadrants. Let me use yellow for this. 1 and 2, quadrants 1 and 2, and our angle, since it is our ratio, since it's negative, means we're in quadrant 2. Okay, so if we have this triangle here, this is going to be negative 12, so this is a negative 12 over here. I'll write that then, just make sure I have space, and the r is going to be 13. A little difficult to see, but we have 13 there. Okay, and so now if we're looking at tangent, right? If we're looking at tangent, tangent is a ratio of y to x. So we need to find the y value here, and the y value, well, that's the unknown here. I'm going to do that in red. That's unknown, so we're going to redraw this triangle over to the side, and so we have 13, negative 12, and y. And we're going to solve for y because we're looking for, that y value. We're going to do y squared, Pythagorean theorem, plus negative 12 squared equals 13 squared. And that's going to give us y squared plus 144 equals 169. And if you subtract that over, you're going to get y squared equaling 25, y equaling 5. So this is going to be equal to 5, and that gives us our y value. Now I state all this, so you're basically starting off with tan theta, right? And we're going to tan, it has to be of an angle, gives you a ratio, y over x. So that's what we are solving for here, right? This is that here, and that is going to be our y over x. So what's y and what x, or what is x? You're going to be getting a y of 5 and an x of negative 12. So this is equal to negative 5 over 12, and that is your answer for this one. Now I just wish to highlight the way if you had trouble with this, the way I would look at this is you're always doing inverse cosine of a ratio, and you're doing your trig function of theta. You're going one way or the other. So you're going to be going ratio to angle, so ratio to angle, or angle to ratio. And it's always going that relationship. So when you're trying to plug things in, if you're trying to lose yourself, I would always start in the center, figure that out, which we did over here. We looked at this and try to relate what the other parts of the triangle were. Okay, and from there we said, okay, well, what's tan theta, which this is theta? What does that represent? Y over x. So we need to find that y and put it over x here, and that gives us our value. So let's look at a different problem that's slightly maybe more difficult to reason out. So for this question, we have rewrite the trigonometric expression as an algebraic expression. Algebraic referring to in terms of some variable unknown, in this case x. So we're going to take this and rewrite it in terms of an unknown x. So give it a go. Alrighty, to start this one off, I like to look at this and say, okay, what do we have here in terms of arc cosine, what is that referring to? Arc cosine, again, if you have this, of x, is supposed to give you, in this case you're doing it of a ratio, right? It's supposed to give you theta, right? And now, this is where it might be confusing. What does this x represent? You might say, well, it represents the x-axis. I would say possibly yes, but it's not always guaranteed, especially when you're dealing with tangent. It's just representing an unknown right now. So in this case, I would say if we're considering the unit circle, so r equals 1 here, it actually does refer to x. So in this case it does, because we have x over r being equal to the ratio for cosine, right? So with that being said, if r is equal to 1, this x and this x are actually identical in terms of they equal the same thing, but it could have been, just to give you a heads up, this could have been, I don't know, some variable w, and it would have been w is equal to x for this setup. So it doesn't really matter what that was, it's just more to say what that x variable is. If you didn't catch that, that's fine. Just try to note in the future when we deal with tangent, it's going to be different. All right. Going forward, let's just quickly note that on the unit circle, let's just give some angle here, reference angle alpha. In this case, we have x, and this is r. R must be equal to 1. And now for sine, right? For sine, if you're doing sine of this whole thing, it's supposed to give you, a ratio. This is going to be y over r, but it has to all be in terms of x, your unknown variable. All right? So if it's in terms of x, your unknown variable, you have to consider the following. What is y? How do we solve for y? Well, y squared plus x squared equals 1 squared. So if you're looking for this, y squared is going to be simply equal to 1 minus x squared, and then you're going to take the square root of this whole bit here. And we just said that sine is y over r, right? So I'm going to highlight that, right? Y over r. Well, since this is 1, right, we're going to say that this is simply equal to y. Well, if we just solve what y is down here, this is going to be equal to our actually final answer. This is an algebraic expression to say what y is equal to. 1 minus x squared. If you lost me at a certain point, make sure to rewind and rewatch, and make sure you're catching up and write down any questions you may have. Okay, let's handle another type of problem. For this setup here, we have solving for theta when you have theta from 0 to 360 degrees for this equation here. So let's try this out. So getting right into this, we're going to start off by dealing with this part here because we don't want to deal with multiplication or division first. So we're going to do some subtraction here. Subtract 9 over, and you're going to be left with 3 cosine theta equals negative 2, and then you're going to divide by 3, and you're left with cosine theta equals negative 2/3. And now, this is where you want to use your calculator, because this is not an easy, this is not one of our special angles, and do inverse cosine of negative 2/3. Okay, and if you do this on your calculator, you should get, if you round to the nearest hundredths, approximately, I did the equal sign, should have done approximate, 48.2 degrees. Now, if you're wondering how to do this on your calculator, you look for the trig button, right? And you look for, it looks like square button here, and you're looking for cosine, and it should be right above it in cosine inverse. And that's going to be the one you press with shift, then that button. So you're going to press this button once you press shift. Shift, and that button. Okay? And just make sure you're in the right mode, and mode, it has to be in degrees. So mode, degrees, just for your notes. Okay, last but not least, I want to talk about this idea of the unit circle again, and quickly draw this out, and talk about this measurement here on the unit circle. Now, if we look at the unit circle here, we have two different parts. We have a point along the unit circle, point P. Point P is representative of this angle theta, right? This is measure theta, and this length r, this radial r. We can note point P as theta, put that here, comma, r. That's one way, and this is a polar coordinate. So let me write that down. Polar coordinate. However, there's another way of actually writing, which is a Cartesian way, and you'll be looking at that as x and y's, because typically we've done that before by going, this is the x, you look x over, and then you go y up, right? And that gives you an x and y component of your point P. And that makes our right triangle. So we have another way of writing it as x and y. So how do we get to that, right? Typically, we've been looking at that through the lens of Pythagorean's theorem. But let's take another look at it and say, hey, what if we had a line here going through this? I'm going to see if I can line it up. Going through, let's say this was some line, right? Y equals mx plus b. In this case, b is going to be the origin, so we're going to get rid of the b. There's the y-intercept is 0. So y equals mx, right? So if you're actually trying to calculate m, right? M here being the slope. M equaling slope. If I'm trying to calculate this, m is going to be simply the change in y over change in x. Now, note something here. If we have x and y, right? X and y, we've already had relationships established in the past. X being cosine theta and y being sine theta. That if we actually do this change in y, change in x, we can say that our initial point, the final point I should say, y is going to be sine theta minus 0, because that's the origin. That's where you're going to start from. We're going to go from here to here, I should say, so origin to point P. Okay? And you're going to have cosine theta minus 0, making it so that sine theta is just over cosine theta, and that's equal to your slope. So let me highlight this. I'm going to circle this in yellow. So notice these two things. Sine theta over cosine theta is equal to slope. Well, we've also seen sine theta and cosine theta over cosine theta equal to something else. And yes, that is tan theta. Tan theta is equal to sine theta over cosine theta. So what actually was very interesting is if you're trying to find the slope of a line, you can actually find the slope of the line being equal to tan theta, which also gives you, if you find tan theta, equaling m, right? So this is all equal to m, that if you actually find that tan theta is the slope, you can find the angle of your elevation, right, of this line, if this is the origin, like this is some ground level, right? So if you have some horizontal, this theta here is going to be your angle of elevation. So this might have been a little bit confusing. Let's just try a problem out just to finish this up. So I want to note, I think I said angle of elevation. I meant angle of inclination. So find the angle of inclination for the line 2x plus 5y equals 15. Now, for this one, I'm just going to go right into it and say, I don't like the way how it's now in y equals mx plus b form. So in this case, I'm going to move everything over and say we're going to have 5y equals 15 minus 2x, and then divide by 5 to both sides. And you'll be left with y is equal to, let's put 15 minus 2x over 5, and I can simply reduce this to 3 minus 2/5 x. And this is all equal to y. So that's equals y equals mx plus b form. Now what's interesting here, knowing that this is the slope, right? So here, this part is the slope. This is m. We just said m is equal to tan theta. So if we write this, or we have this here as negative 2/5 is equal to m, we can actually get the angle of inclination by just doing arctan of negative 2/5. And that'll give us our angle theta, which is our angle of inclination. So if you plug that into your calculator, remember you use arctan or shift tan button, you're going to get approximately, and I keep forgetting that I'm missing the approximate symbol, which is negative 21.8 degrees. Now, that's because arctan goes to quadrant 4, right? 1 and 4, and the negative quadrant is 4 in this case. So that's the 21.8 degrees, but note something very interesting about this, that we have this, that is not actually our angle of inclination. Our angle of inclination would be, so if we draw a quick picture of this, right, this is, we have 3, so it's intercept of right here, let's say, and negative 2/5, right? Let's just draw a quick line. That's a horrible line, but we're trying to get this angle, right? We're looking for this angle right here. This is what the angle of inclination is, theta. So this here, 21.8, represents our reference angle, right? This represents our reference angle. And we want to, so that's in here, we want to get this other angle on the other side. So we're going to take this and take the difference of 180 from this. Now note, the reference angle must be positive, so reference angle is equal to 21.8 degrees, and we're going to take 180 degrees, subtract 21.8 degrees, and that's going to give us our theta, which is equal to, I should have read approximately 158.2 degrees. And that's going to be equal to our angle theta. Alrighty, sorry for the long video today, but I hope this was overall helpful for you and your studies. I'm looking forward to seeing you all next time. Have a good one.